Any ideas what that might mean? Optimization. Finding optimal amounts. Finding essentially what we're doing is maximizing and minimizing functions. Finding maximums and minimums, which is what we've been doing, right? We've been doing first and second derivative tests to find maxes, mins, points of inflection, all that good stuff. So we're going to use kind of that same kind of strategy, but here's the hard part. You're going to have multiple equations. You're going to have to solve one in terms of another to plug into another one. It's going to be, the algebra we do in here is just on crack anyway. So that's going to be the hard part of it, is not the calculus-y part of it, but the algebra part of it. So what we'll do is we'll have some function, and we'll have to define the functions. One more. And I can just give you a general strategy. I know y'all like steps and everything, but just in general, we'll have multiple functions. And we will have to get a certain function, whichever one I'm maximizing or minimizing, in terms of one variable only. So we'll use all these other functions to help us do that. And then we'll proceed like we've been doing, which is derive, first derivative test, find maxes and mins. Sounds easy, right? Mm-hmm. I found my notes where I taught this last year. That's what I should do. I should just start pulling from last year. Let's start easy. Do I? Yeah, I know. That's what I'm saying. While I had such a good rate, I should just, whatever I did last year, keep doing it. Keep doing it. All right, let's do an easy example first, and then we'll move into a little bit harder. Find two numbers. Let me just write it for you. Find two numbers. Sometimes I feel like that guy on Khan Academy. You know how he says something and then he starts repeating it as he's writing. Find two numbers. So find two numbers. Okay, find two numbers. Whose sum is, and I'm getting this straight from your book, from the example. Whose sum is 20 and product is as large as possible. So I often have trouble determining what I need to find, what I have, what I can even do. So I like to break these up in, and you do not have to do it this way. This is just my way of thinking. The first thing I like to do is, what is it that I'm actually trying to find? What do I need? What do I need to find? So the question is asked, this doesn't have anything to do right now with what I'm trying to find. The question is a product as large as possible. So what I'm trying to find is a max of the product of two random numbers, right? So I'm going to use two different variables because they're two different numbers. Do you agree with that? Okay. I want this to be as large as possible. Do you agree? So I'm going to say, and actually, let me not use X and Y. Let me use A and B. Well, okay. I'll use X and Y. That's fine. I'll use X and Y. And then what do I have? What have they given me? Because they've given me something to help me tackle this problem, right? So what is it that they've given me? Well, they've given me that the same two numbers have a sum of 20. Well, what does that mean? That means that if I add them together, I get 20. Okay, so I'm going to use the equation that I have to find the max or the min of, but I need that to only be in one variable. So what I have to do is take what I have here, solve it for one of the variables, plug it back into the function that I'm maximizing, and then I can go through and find the maximum. The only thing they gave me was what's in green. Right. So this is what I'm trying to find. So it's what I need. And this is what they gave me to help find those values. So what I have. What I have versus what I need. Okay. So what I'm going to do is I'm going to come and you can solve it for either variable, whichever one's easier, right? Here. So maybe I just solve it for, I don't know, what do y'all want to solve it for? It doesn't matter. Y. Agree or disagree? Agree. So now my function, which is just going to be a function of x now because I'm not going to have a y in there anymore, I'm going to replace the y with 20 minus x. So now my function is x times 20 minus x. Again, this is an easy one, right? I hope anyway. It's going to lead us into some good ones. Well, now I have a function that I can maximize. I can find the maximum because that's what it asked me, right? The product is as large as possible. So I want the product, I want this to be as big as possible. So I want to find the max. So to do that, first derivative test, right? And I'm going to probably, I don't want to do product rule, so I'm going to do 20x minus x squared. We're in Algebra 2, this is an easy one to find a maximum of because it's just an upside down parabola, but since we're in calculus, we'll derive it. So we have 20 minus 2x set it to 0. What's my x value here? 10. Let's hope that's a maximum and not a minimum, right? Sign of the derivative tells me what the function's doing. What's the sign when I'm smaller than 10? Remember, I'm looking at the derivative. So 20 minus 2 times a negative number, positive. What's this? A maximum. So the question is, find the two numbers. What have I found? I found one of the numbers. I found x, right? Because I wrote that in terms of x. So I know x equals 10 and y equals what? 10. Plug it back in, right? And you know that y equals 20 minus x. I know they have to add, right? So what's the greatest possible product? 100. Because, well, I needed to know the y, right? I needed to know what is that y value. I need both values because I'd written my equation just in terms of one. So you're flipping back and forth between what you're using, which makes it all the more confusing. So the max product, and this is kind of like where we talked about the max value versus occurring at kind of thing. So the max product is 100. The two numbers. Because if you look back, they told you in the beginning the sum of the numbers is 20. So they have to, the two numbers have to add to 20. So if x is 10, y has to be 10. Y'all ready for a real one? Yay! This is number 2 from your homework. Maximizing area. What's the largest possible area? Let me not. I keep looking up at y'all and then losing my place where I'm reading. For a right triangle, so I'm looking for largest area. Right triangle whose hypotenuse is 5 centimeters long. What are its dimensions? That's not a lot of stuff, right? Find the largest area of a right triangle whose hypotenuse is 5 centimeters long. What's the largest possible area it could have? Okay, so let's look at what we need to find and let's look at what we were given. How about that? Okay. What do we need to find? Or what are we asked to find? The what? Largest area. How do you find area of a triangle? Okay. This is the function that I'm maximizing, right? So area is 1/2 base times height. This is my equation that I'm going to take the derivative of, that I'm going to do the sign analysis of, but my problem is I don't have any, I can only have one variable in here, right? So I've got to come up with some way to get this in just one variable. If it was in just one variable now, I wouldn't have a problem. But the problem is, right? So what was I given? I was given the hypotenuse. Right triangle. Yes, you're exactly right. Okay, so let's go with that. You said if this is A and this is B, let's use some variables that we already have though, because technically in this triangle, A is my what? Height. So let's call it height since we've already got this variable here. And this is my base, right? In other words, if I wanted the area of this particular triangle, here's my height, here's my base, right? Okay, so now do your Pythagorean theorem. That means that I know that what has to happen? Exactly. Are we all okay there? Now remember the goal. The goal was to get this equation that I'm trying to be able to derive in just one variable. So now I've got another equation that relates those two variables. So what can I do? That's exactly right. Solve it for one of them and throw it back in there, right? And then we'll maximize. Well, okay, which one you want to solve for? Doesn't matter. Height, okay. H squared equals 5 squared minus b squared. Square root. This is technically a plus or a minus here. Bless you. And now I can take this and replace this. Replace not B, but H. Now I can write my area as a function of the base. 1/2 base times my H is now the square root of 25 minus square. Y'all okay? Now comes the calculus. Find the maximum, right? What was I trying to find in the beginning? The largest area. So maximize area. Find where the maximum area happens. Okay. I know to do that I need to take the derivative. I think this is fun. Don't y'all think this is fun? Even if you don't, just come in and pass the fun. Yes. Thank you. Yes. I'm glad y'all are happy about it. Okay, let's do product rule. Derivative of the first times the second. Was your class at Lugoff this quiet? Were they? We get a lot done and just dig down, I think, and it's good though. This is a very studious class. This is a good class. All right, do the first times second plus the first. I should have pulled that 1/2 out to start with this. Okay, times derivative of the second. Don't forget to chain. Oh, I hate when I'm out of room. I changed this to 1/2 exponent, so I can use power instead of. I'm sorry, this is very pretty. Don't forget that. Yeah, don't forget to change. Change. I guess we'll clean it up a little so that we can. You know, this looks like these problems we were doing where we were finding a common denominator. I bet it is. I'm gonna make this minus because of this negative. I'm gonna go ahead and cancel at least one of those 1/2s out there. Looks like I'm gonna have b squared over 2 times the square root of 25 minus b squared. Is that what y'all got? 1/2 is still there. b 25 minus b squared. Y'all okay? Yes, no, maybe so. Say again. Yeah, because I had 1/2 times 2 would cancel out, but then there's still another one out there. All right, let's get a common denominator. 25 minus b squared. 25 minus b squared minus b squared over. Now we're back to what we've been doing for what feels like forever. Yes. Yes. All right, find them. See what happens. Now, let me ask you this before we start. Are you restricted at all in the beginning? Yeah. I can't be what? Look at that triangle that I know. I can't be negative. Yeah, I got to be less than 5. Why? Hypotenuse has got to be the longest, right? I have no other choice for that. So I can automatically, if I get some crazy numbers, I already know that I got to be bigger than 5. I mean, smaller than 5, sorry. Right? Because this was my original triangle. It said, you can't have a negative length on the side. 0 and 5. Right? Yeah, go ahead. So, yes, but you couldn't be negative initially. Like, you see what I'm saying? Like, it would satisfy Pythagorean theorem, but it wouldn't satisfy being a triangle. You see what I'm saying? So from the very beginning, my domain restrictions are going to be from 0 to 5. Remember how we look at that function initially and we say, are there any restrictions so I don't have to do any more than what I... Now, if you included it and then you looked at it, you go, oh, wait, that doesn't work, and you'd know. But if you recognize it right off. All right. Top and bottom to 0. I'm going to rationalize that denominator just a bit. 5 root 2 over 2. Yep. Because look at the variable you're looking at, right? You're really looking at b. What is b? Well, b is the side of a triangle. You can't have a negative side of a triangle, right? Yeah, so we just said positive. All right, did y'all get 5 root 2 over 2? Yeah. Any undefined points? 5. If you set this to 0, it's 5. Well, 5's already on there, right? Negative doesn't matter. The 5's already there. It's an endpoint for me anyway. So I'm ready to test. What I'm hoping, since it asked me to maximize area, I'm hoping this is a maximum, right? Then it wouldn't have a maximum. You would say it doesn't, yeah. Then you're not going to get one that's not going to, though. If you do, you've done something wrong somewhere. But you could get one that has a max and a min, and you have to choose the right one. Or if you don't have one on there, what you would, actually I shouldn't say, test these endpoints and see which one has the highest value, and then that would be your maximum. All right. What do you get in between 0? Okay, 5 root 2 over 2. That's like, let's pick maybe 1. That's smaller, right? It's positive. I'm going to assume this is negative. Well, that's good to know, but I still haven't answered the question, because the question was, what's the largest possible area and what are its dimensions? All I have found right now is the base of the triangle that has the largest area, right? You understand what I'm saying? Right now, I know that the base of the triangle with the largest area, that base is 5 root 2 over 2 centimeters long. I need the height and I need the area. So what am I going to do? Plug it in. Just plug it in. What am I plugging into? I need a height. Well, what does height equal? Go back. You already found what height equals. Height's the square root of 25 minus b squared. Okay, well, square root of 25 minus b squared. If I'm on an FRQ, I stop at this point right here and write centimeters and be done with it. But let's simplify it. Yeah. No, don't be sorry. So I took this base and I said, if the base is that, how do I find out what the height is? So I went back up to where I found out h equals square root of 25 minus b squared. And I just plugged in for that b I found. We're constantly finding a variable, plugging in, finding a variable, plugging in. And then I would need to do 1/2, yeah. I am gonna, this would be a non-calculator problem. Let's see. It may simplify down, but maybe not. What do you get here? 2, so that would be, does this come out nice and neat or no? 25 times 2 is 50. 50 over 4. So no, it doesn't come out nice and neat. Right? Is that what y'all got? Thank you, Preston. 25 over 2, which is, it's the same thing. It's an isosceles triangle, y'all. It's an isosceles, that's okay. It's an isosceles right triangle. 5 root 2 over 2 centimeters. Well, because you got 5 over, the square root goes to both. And then rationalize that denominator. Oh, that becomes 50 over 2. But then make sure you subtract the 25 over 2, because then I just dropped it off. So now Henry's exactly right. We still haven't answered all the question that they gave us, which was the area of the triangle. So the area here would be 1/2 base times height. No, I know, right? Which is 25 times 2, which is 50. 248 centimeters. Don't forget your units, you'll lose your answer point. Depends on what kind of question you're in. We'll simplify just because we're, what is that, 25 over 4 square centimeters. Well, 5 and 5 is 25, right? And then root 2 times root 2 is 2. And 2 times 2 times 2 is 2. All right, this is going to be hard. I have a feeling I will probably be working homework questions for a while tomorrow, but I do want you to try it. Try as you set these up to list what you're trying to find. Always identify the function that you're optimizing first, and it will help you. And then look at what you're given from there. But always look at the question that's asked first, because it'll help you. All right, we're going to do 239. I doubt you'll make it through all those, but at least get a good head start on it.